just try to keep it short and make sure we cover the important materials here, and hopefully you'll find it useful in the exam. Okay. Now, what I want to do is I will complete the linked layer study. Okay. So one thing which is very important is if you still remember last time when we talked about setting the default gateway. So what it means is if you have a routing table and you want to send the data to some outside internet. Okay. Now one thing is you set the routing table entries. Okay. You give a destination address. Okay, and then you specify the output interface. Now what happens if the destination address is not defined? So what it does is it will send to the default gateway. Okay, and the default gateway will help you forward the packets to the final destination. Now the question is, how do you send the data to the default gateway? Okay, so what it will do is you first find the MAC address of the default gateway. Okay, and then you send the data using the linked layer protocol to the default gateway. Now how to find the MAC address of the default gateway? And in here, we will use a protocol called ARP. Okay, and the ARP basically stands for Address Resolution Protocol, which try to resolve the IP address to a MAC address. Okay, so I will explain what that means in here. Okay, now first of all, in the linked layer, we will look at the Ethernet implementation. Okay, so there are many linked layer implementation. Now, the one that we are looking at is the Ethernet. Okay, so when you buy a network card, basically there will be a address. Okay, this is what we call the Ethernet address, or sometimes we give a name called the MAC address. Okay, now what is the difference between the MAC address and the IP address? Okay, so the IP address is 32-bit IP address. Okay, so this is the what we call the network layer address. Okay, and we use this to send the datagram to the destination IP subnet. Okay, so given the IP address, okay, you run the routing algorithms and then find the next hop, and eventually you will send the data to the destination IP subnet. Okay. Now there's another address which is called the Ethernet address. Okay. So the idea is you send the data frame from one interface to another interface within the same network. Okay. And if you still remember, in the link layer is the point-to-point communication over a single link. Okay. So you send directly using from one interface to another interface over a single link, and the point and how you send this is to use the MAC address. Okay. Now this MAC address is a 48-bit MAC address. Okay. So it's different from the traditional 32-bit address. Now, so what that means is that okay, each LAN card will have an IP address, and there's also a MAC address. Okay. Now, why do we have two addresses? It's just because they are two different layers. Okay. So IP refers to the network layer, and the MAC address refers to the Ethernet layer. So in here, you will see that actually every network card will also have a Ethernet address. Okay. Now this Ethernet address is 48-bit, so it is 6 bytes long. Okay. So you may find out the MAC address in here like this. Okay. Now in Linux, you can type ifconfig and to find out what is the IP address. So in Linux, if you just type in the command ifconfig, it will show you the Ethernet address, okay, of your network card. Okay. Now this address is assigned by a IEEE community. Okay, it's centralized. It's a centralized organization that assigns the MAC address to each interface card. Okay. Now the idea is like this. Okay, so every network card will have a unique MAC address. Okay, so whenever you buy a computer, okay, inside your computer you have a network card. Okay, this network card will have a unique Ethernet address, and this address is unique globally. What it means is that your computer, okay, your network card, and maybe your laptop's network card will have different MAC address. So one thing that you need to know is the MAC address is unique globally. Okay, so different network cards will have different Ethernet address. Okay, so this MAC address is centrally assigned by the IEEE community. It's just like your Hong Kong ID. Okay, so everybody has its own ID. Okay, and IP address is more like the postal address. Okay, what's the difference between the Hong Kong ID and the postal address? Now, so for postal address, there will be a hierarchy. So it starts from the street address. Okay, and then within the street, you identify the building and then the room number. So in the IP address, there will be a hierarchy. While in the Hong Kong ID, there will be flat. Flat in the sense that you and I, okay, your Hong Kong ID and my Hong Kong ID will have no structure at all. Okay, it's just some random number which is assigned by the centralized authority. In the case for Hong Kong ID, that would be the Hong Kong government. Okay, so we also sometimes call the MAC address to be a flag address in the sense that there's no hierarchy. Okay, so each MAC address is just like a random string. Okay, with 48-bit unique string. Okay, so this MAC address will be associated with each network card. Okay, you can move from one LAN to another LAN. Okay, however, the MAC address associated with this LAN card is always unique. Okay, and this is portable in the sense that when you move the card from one place to another place, the MAC address will still be the same because it's always associated with the network card. And on the other hand, for the IP address, you cannot move the IP address from one place to another place because this IP address must be associated with the subnet. Okay, and you cannot move the subnet. Okay, so for example, if you have an address 137.189.90.6, for example, you cannot move the address to the United States because this IP address must be within the CUHK network. So in here, that's what it means by non-portable. What it means is the address will have to be associated with the IP subnet to which the node is attached. Okay, so you have to distinguish these two things. Now the thing is, how am I able to find the MAC address and the IP address? So the idea is, given the IP address, I want to find the corresponding MAC address. Okay, so how do I do that? And the idea is based on the address resolution protocol. Okay, one example will be to determine the default gateway's MAC address. Okay, so you specify the default gateway's IP address. Okay, when you want to send data to the default gateway, you need to figure out the MAC address first. So the question is, how do I do that? Okay, and this is based on the address resolution protocol. Okay, so in fact, inside each node, okay, there's a table called the ARP table, which stores the mappings between the IP address and the MAC address. Okay, and there's also an entry called the time to live. Okay, which is to specify the expiry time of the address mapping. Okay, so for example, if you say that it is 20 minutes, what that means is this mapping is only valid for 20 minutes. Now actually, in Linux or in Windows, you can always specify the you can check out your ARP table. If you just type ARP-A, it will list out the corresponding IP address and the mapping. Okay, so you can see that there's an IP address and there's also the physical address. This looks a little bit funny because so more than one IP address is associated with the MAC address. Okay, maybe I use another computer to do that. Sorry, I actually don't know why more than one IP address is associated with the same MAC address. Theoretically, these two should be different. Okay, so one IP address should be associated with a different MAC address. Okay, I'm sorry about that. I don't know what happens in here. But in any case, if you type in ARP -A, you will find out the corresponding mapping. Okay, dynamic means that it is learned by the ARP protocol. Okay, while for the static, if you see from here, this is hard code. Okay, so what that means is that this this mapping is hard coded inside the ARP table. Okay, but in any case, if you type in these hosts, you will find out the mappings in here. Okay, I apologize. I don't know why they will be the same in this machine. But probably there's some configuration in the CSC network, but in fact it should not be the case. In any case, what we want to do is we use the resolution ARP protocol to try to resolve the IP address, resolve the MAC address using the IP address. Okay. Now how do I do that? So the protocol is very simple. It's just a request response protocol. So for example, if a host wants to find out the B's MAC address, you will broadcast a ARP query. Okay, and the query will contain the B's MAC address. So the destination MAC address will be the broadcast address, so that everyone will receive the ARP query. And B, when it receives the ARP packet, if it has the corresponding IP address, you will make a response, okay, to tell A what the MAC address will be. Okay, so initially it starts with the broadcast, and then later on it will show you, it will replace a MAC address. Okay, and A will then save the IP to MAC address pair in the ARP table until it's times out. Okay, so it will time out unless it's getting refreshed. Okay, so this ARP table, this ARP protocol is plug and play. Okay, so as long as you need the IP address, it will start the query and then get the reply. Okay, and then you just fill in the ARP table. Okay, so on the course website, I put a trace. Okay, which you can take a look and see why how it works. Okay, again, the idea is very simple. So if you look at the ARP, basically there will be two packets. One is the request and one is the response. Okay, so the request will be the destination will be specified to broadcast. What that means is you send to all the nodes within the network. Okay, and the ARP basically will specify what is the target IP address. So this is to ask which machine will have this IP address. Okay, so there's a sender MAC address and sender IP address, and there's also the fields for the target MAC address and also the target IP address. Okay, now if the host has this IP address, okay, so it will return the ARP reply packet with the corresponding MAC address. So in here, this is the corresponding MAC address. Okay, which means that, hey, I have this IP address and this is my MAC address. Okay, so this is just a simple request response protocol, and this is just how it works. Okay. Any questions? Now, of course, you may be wondering, hey, is it possible for some other host to reply the ARP reply, just claim to have this IP address? Okay, and the answer is yes, it's possible. Okay, so it is possible that there's another host who doesn't have this IP address but pretend to have this IP address. Okay, so actually, if you look at this particular packet, there's no verification. Okay, you cannot tell if this MAC address is really associated with the IP address. You have to trust the host that replies this ARP packet. Okay, so there's also some security issue in here. What happens if there's a malicious host who reply a fake ARP reply just to claim that it has its own MAC address? Against this issue will be covered in the security course, which I won't go into the details in here. But you may want to know that, hey, actually somebody else can maliciously pretend to have this IP address and reply a fake ARP packet. Okay, but in any case, this is just the simple ARP protocol. One host broadcasts a query, and then the host who has this IP address will make a reply. Okay, so this is the whole idea. Now, in any case, so let's complete the whole thing together. Okay, let's say if one host wants to send packets to another host on a different network, how exactly being done? Okay, so actually it will try to combine both the link layer protocol as well as the routing protocol. Okay, so the idea is like this. Let's say A wants to send a packet to B. Okay, now the first thing A wants to do is to try to find the IP address to see if this is in the same subnet. Now, if this IP address, which is 222 in here, is not in the same subnet, the host A will send the packets to the default gateway, which is set to be the this IP address in here. So let's assume that A's default gateway will be 110. Okay. Now, how to send the packets to the default gateway? So in here, the A will send the packet to the default gateway using the link layer protocol. Okay. Now before it does that, it needs to first check the MAC address of the default gateway by using the ARP table. So the idea will be like this. Okay. So A will first create an IP datagram with source A and destination B. Okay. Now if it finds that B doesn't have the B is not in the same subnet, so A will send the packets to the default gateway. So in here, A will use the ARP to try to get R's MAC address for 1110, okay, which is the default gateway in here. Now R will replies the ARP reply. So in this case, A will try to create a link layer frame, okay, with R's MAC address as the destination, and send the frame to the default gateway through the link layer. So the A's NIC will send the frame, and our NIC will receive the frame. Okay, so these two parts will be done in the link layer. Now what the router does is it will first remove the IP datagram from the Ethernet frame, so they encapsulate the Ethernet header and try to look at the destination of B. Now if it knows that, hey, this the destination of B should be in this interface, so it will try to forward this packets to this interface. Now from this interface, how to send it to B? Again, it will use the ARP to get the B's MAC address, okay, and R will try to create a link layer frame and send it to B, okay. Now imagine that there will be multiple networks in here. So if B is in another network again, so the packets will be sent to the default gateway, and then will forward to another default gateway, and eventually it will reach the final destination. So in fact, this is how it's being done in the internet. So when you want to go from one subnet to another subnet and finally reach another subnet, it will go like this. Okay, first you use the ARP protocol to resolve the MAC address to forward to the default gateway, and the default gateway will try to find the right output interface, and in order to forward to the final destination or another default gateway, it again uses ARP to resolve the MAC address and finally send to the another host through the link layer. Okay, so actually this is the way you can combine both the link layer and routing layer together and send to the final destination. Okay. Any questions? Now, please make sure that you understand this line very well. Okay. Just to make sure you understand how the data is being sent to the default gateway, how to decapsulate this and send to the final destination. Okay. So this is the most important slide of this in here. So make sure you understand this part. Okay. Now, the Ethernet basically is the link layer implementation. So there are many link layer protocols, but the Ethernet in here is being used, is the most widely used wide LAN technology. Okay, another link layer protocol will be the 802.11 for the wireless protocol. So for Ethernet, it will be 802.3. Okay, this is for the Ethernet, and 802.11 will be for Wi-Fi. So 802.3 and 802.11 are the IEEE standards. Okay. Which specify how the protocol should be implemented. Okay. Now, in the wide line case, okay, wide network, we use the Ethernet. Okay. So it specifies the protocol, how it looks like. Okay. So in here, actually, it will have a header like this. Okay. So there's a destination address. Okay, which is the MAC address. The size is 6 bytes. Okay, 48 bits. There's also a source address. Okay, so this source address again is also 6 bytes, and there's a type field which specifies the following protocol. Okay, so if you look at the trace in here again, okay, so there's an Ethernet header which has the destination MAC address and the source MAC address and also a type field. Okay, this type field set specifies what the protocol it is. Okay, so if this is an ARP protocol, then it will be this value. Okay, if this is a IP packet, which means that what the link layer payload is an IP packet, then this value will be 0800. Okay, if this is ARP, this will be 0806. Okay, so IP in here will be 08. ARP. So, so the type basically specifies what the protocol is. Okay. Now, in the Ethernet, if you look at trace in here, okay, so it will start all the way from the destination MAC address, okay, and then the source MAC address, okay. Now, notice that as I mentioned in the last lecture, there's also some fields which you cannot see. Okay, actually there's also a preamble field and also a CRC field. Now the preamble field basically is to specify the beginning of the link layer frame. Okay, so it will start with the pattern 10101010. Okay, followed by 1 byte with a pattern like this. So what is being used in here is to try to synchronize the receiver and also the sender clock rate. Okay, so they will use the preamble to specify the beginning of the link layer frame. And there's also other field which you don't see from the trace is the CRC. Again, this CRC is a checksum to specify the integrity of this link layer frame. And again, this is CRC is also used for the synchronization, so that the receiver side knows when this frame will end. Okay, so this preamble and CRC is also part of the Ethernet protocol, although you don't see these two fields in the link layer frame, but they are being used to identify the beginning and the end of a data frame. Okay, once it's being captured by the receiver, these two fields will be removed, and these things will be sent to the upper layer. So what you see from the Wireshark in here will be the destination address and the source address and the type field. Okay. Again, this is just what I said. Okay, so the address, each of them will be 6 bytes long. Okay, if the adapter's MAC address matches the destination address, or the destination MAC address is a broadcast address, okay, so this network card should take this frame, okay, and then it will pass to the network layer. And otherwise, this adapter or the network card, okay, so basically it will discard the frame. Okay, so adapter here, just the network card, okay. Now, type field basically specify the high protocol. For example, for IP, that will be 0800. and ARP will be 0806, okay? And the CLC will be the checksum to specify this is the if the frame has been corrupted or not, okay? Now, Ethernet by itself, if you don't put in any checksum in here, that will be connectionless, okay? Well, first of all, there's some property regarding Ethernet. One thing is there's no handshaking, so it's not like TCP, okay? You don't first set up a connection, okay? You just send the frame directly to the receiver side, okay? And it's unreliable in the sense that the receiver network interface card won't send acknowledgement back to the NIC, okay? So this is something that should be filled in. This is to be done by the TCP, okay? So this is how it works. But I'd like to point out that this is only the Ethernet implementation. Okay, for wireless implementation, for Wi-Fi implementation, they actually provide the acknowledgement. So what it means is when you send the data to another host using the wireless medium, they will reply an acknowledgement to make sure that the communication is reliable. However, in the Ethernet, they don't do that, okay? So the reliability basically is being handled by the upper layer, which is the TCP, okay? So they assume that the higher layer will implement the reliable protocol. And the Ethernet MAC protocol will use the CSMACD to detect if there's any collision. So what that means is if another host sends the frame at the same time, okay, there will be collision. So in this case, they will try to detect a collision and take the action, okay? In this case, if there's a collision, they will try to retransmit, okay? Retransmit the frame to another side. Now, however, there's no acknowledgement, okay? So if there's no collision and when you want to send the data to another side, okay, it's possible that the data may be corrupted. So in this case, the Ethernet will try to use this CRC code to detect if there's an error, okay? So this is pretty much like the TCP checksum, okay? However, this is more robust in the sense that if there's a bit error, okay, this checksum can identify it, okay? While in the case of TCP, it is possible that you flip a bit, but the checksum will reflect that this is correct, okay? So there could be some false positive in the high layer checksum. However, in the Ethernet, there will be no false positive. So if there's a bit error, the checksum will find out there's an error. So there will be mismatch. If this is correct, the checksum will match, okay? There is a very small probability, a case that the checksum and the payload will match, but there's actually a bit error. So this is not likely happen in the Ethernet. Now the key point in here is that they rely on the TCP to provide a reliable transmission. However, they also use this CSMACD and also CLC to provide a certain reliable level of communication. So even though they don't use the acknowledgement, but they still try to do their best to guarantee that no error is being introduced. Okay. Any question? Now this is what you need to know about the Ethernet. Okay, there are a lot of details which I don't discuss, but the thing is, you just need to understand the ARP protocol and also the Ethernet header. Okay, so how the header is being formed. Now there's another thing which is about the link layer is how to connect two hosts together. Okay, now one thing is, of course, one thing you can do is just pull a wire to connect two things together. Okay. Now, however, if the network is in different places, just like in this building, okay. If I want to connect all the computers, which is in the same local area network, okay, using the wire, even though this is just for this particular floor, this is not feasible because you have to pull the wire very long. Okay. Now what we need to do is to use some device